Hello everyone. In this video, we will do another example for sample spaces. First, recall that a sample space for an experiment is a partition of all outcomes of the experiment. But by partition, we mean that there are two things. It is complete, and well, that's the first one. And the second one is that its elements are mutually exclusive. Meaning that any two of them you consider that they have empty intersection. Okay. So let's do an example here. So we have a box, 3 dimes, 3/4 are there. 4 coins are selected at random from the box without replacement. So you just take out coins from there, 4 of them. Which one of the following sets would qualify as possible sample space for this experiment? Okay, so in each one of these guys, we have to check two things: completeness and mutually exclusive entries or elements. More dimes than quarter, more quarters than dimes. Well, here you have to note that we have 3, 3, and we are choosing 4. So there's a possibility that we have 2 dimes and 2/4 as outcome, and that is not included here. So S1 is not complete, but its elements are exclusive, so their intersection is empty. If we have more dimes than quarters, then the other one is completely opposite of that one. So here, not completely, just they don't have. So the elements are exclusive, mutually exclusive. So, well, that means that it fails, and this is not a sample space. Let's check this second one. 1 dime, 2 dimes, 1/4, 2/4. So here, here 1 dime mean that, well, the next 3 is quarters, so we will get 3/4 here. Let's just list all the possible things. 3/4. 2 dimes, 2/4. 1/4 means all 3 dimes will be there, and 2/4 mean 2/4 and then 2 dimes. As you can see, these two are the same thing, so it is complete, but does not have mutually exclusive the elements. So here, if we didn't have this one, then it would be a sample space, but S2 as it is given is not a sample space. These two are same. S3, 2 dimes, one odd number of quarters. Here you see 2 dimes means 2 dimes and well, then 2 quarters. Here then it means that odd number, so odd number 1, we can have 1 quarter, as a result 3 dime. Or for the second one, we can have 3 quarter, as a result 1 dime. So odd number, it means that. As you can see, it includes all the possible cases. So S3 includes everything, all possible outcomes. So it is complete. And well, how about the intersection? Do they have intersection? If we have odd number of quarters, then the number of dimes will be either 3 or 1. So we will have only odd number, or 1 or 3 dimes. And it is obviously different than, or it doesn't have any intersection with the first one. So S3 has mutually exclusive elements. So both of the conditions are satisfied. S3 is a sample space. Even number of dimes, odd number of dimes. So even number of dimes means 2 dimes. We cannot have 4 dimes because there are only 3 dimes. So 2 dimes and 2 quarter. Odd number of dimes means 1 dime, 3 quarter, or 3 dime, 1 quarter. And as you can see, it is complete and has mutually exclusive entries or elements. As a result, S4 is another sample space for the experiment. Being completeness, having mutually exclusive entries are 2 conditions that you have to check for sample spaces.